Welcome to physics class. We have a train moving at constant speed for 40 minutes, 50, 20 minutes, and then we know that distance is equals to speed times time, and velocity times time, which is velocity, and we have 40 minutes. So the change in displacement, which means change in r, is going to be change in first displacement plus change in second displacement plus change in third displacement. And then from there we know that change in t is the same thing. That will be change in t1 plus change in t2 plus change in t3. So we have three intervals. Alright, then from there we know that change in displacement 1 is going to be speed, that's a velocity, multiplied by time. Okay, so from there we know that our speed is 60 km per hour, and then our time is 40 minutes, so that's 60 km per hour. Okay, so over hour multiplied by 40, and then that's 40 minutes multiplied by so we're converting it into hours, so multiplied by 1 hour over 60 minutes. So the minute cancels and the hour cancels, and then we have kilometer. So we know that we have 60 kilometer multiplied by 40, that's 240, divided by 60, that's 40. So that will be our distance is 40 kilometer, and then that's our x component, which is I according to 2 or 3 dimension, and then that is our first displacement. And then from there we need to find our second displacement. So our second displacement will be constant speed 60, and then our time is our 20 minutes. So we have 20 minutes there. Okay, and then that's our angle that we have, so it's 20 minutes. So remember, we divide that by 60 to change it to hour, and then that is going to be 60 times 20 divided by 60. So that means we have 20 kilometer, and then that is I, or else yeah, but then we need the direction. Okay, so that's 20 kilometer, but we need a direction there. So direction there is 50 degrees, so 50 degrees east. So we're going to say we have change displacement, that will be 20 kilometer multiplied by cos. Yeah, that will be multiplied by cos for the horizontal direction. So multiplied by cos 50 degrees, that will be cos 50 degrees, I plus 20 kilometer, all that multiplied by sine 50 degrees. Okay, so that's J. And then from there we know that we can use a calculator to find the equivalence. 50 degrees multiplied cos 60 degrees multiplied by 20 is 12.9. So we're going to have 12.9 there. Yeah, so that's going to be 12.9 kilometer I, and then we have sine multiplied by 20, that's 15.3. So that's 15.3 kilometer, which is J. and then that's our second displacement. And then moving up, we have third displacement. Third displacement, it says that it moves for 50 minutes west. So west is going to be negative 60 multiplied by 50. Remember, the constant speed is the same, 60 km per hour. So 50 divided by 60 to change it to hour. So we're going to have 60 multiplied by 6 is 1, so it's going to be negative 50 kilometer, all of that J. And then from there, well, that's our third displacement. So from our third displacement, now what we do, we have to find change in T. So changing displacement, okay, let's add all the displacement together. So that's gonna T displacement 1 plus displacement 2 plus displacement 3, and then that means we have displacement 1 is 1, that's 40 kilometer I, and then we have displacement 2, which is 12.9, and I plus 15.3 J. So 12.9 plus 15, that's supposed to be I. So yeah, it's J, that's east. Yeah, that's I think we have a problem there. This is supposed to be I, so it's negative 50 I. Okay, so I and that, and then and that. So let us add all the I components. West, so yeah, so west, that's horizontal, it's gonna be negative I. So 12.9 plus 40 that's 52 minus 50. Okay, minus 50, that will mean we have, which means we have 22.9, so that's gonna be 2.9 kilometer I. And then J component, J component, that's the only component we have. So our J component will be 15.3. That's the only J component we have, so it's going to be 15.3 kilometer, all of that I. And then from there we have the change in T, which is change in T, which is 40 plus 20 plus 50, so that's all the time taken, divided by 60. Alright, we use a calculator. That will be 40 plus 20 plus 50, that's 110, divided by 60, it's 1.8. So it's going to be 1.8 hour. And then average velocity is going to be total, that will be total speed divided by total time. Okay, then that would be the total speed there is 2.9, so that's 2.9 kilometer, all of that I plus 15.3 kilometer J. So that's the X and Y component, that's a 2 dimensions so far. And then from there, all that divided by 1.8 hours, so that would give us 2.9 divided by 1.8 is 1.6. So it's 1.6 kilometer per hour I plus, and then we say 15.3 divided by 1.8, so 17.2 to decimal, that's going to be 8.5. So that's going to be 8.5 Okay, that will be 8.5 kilometer per hour. All of that J, and then we need to find the resultant. Okay, so that's going to be root of 1.6 kilometers per hour multiplied by 8.5 squared. So this goes is gonna be 1.6 squared plus 8.5 squared is 74.8 squared, so root of that is 8.6, so it's going to be 8.6 kilometer per hour. So that's the average speed. Then looking at the angle is the inverse of 10. So inverse of 10, the J component over the I, so that means it's Y over X. Okay, so it's vertical over horizontal, so we have 10 inverse of 10, that's 8.5 divided by 8.6 divided by 1.6, 8.5 by 1.6, yeah, so that will give us 79.3 degrees. So that's our final answer. So that gives you, let's just look at the path that the train took. So that is going to be there is displacement 1, displacement 2, and then there will be displacement 3. So that's the resultant there. So we have the resultant, displacement 3, and then we have J there, and then we have I, and then we have east north, and then we have 0, that's theta there, that's our angle for our resultant displacement. Yeah, that's it. That's how we approach the problem. And if you have any questions, please do not hesitate to leave any comment below. Yeah, so that's it. That's a final answer. Thank you so much for watching. Any comment, please leave below. Thank you.